Next up, we'll be hearing from Rob van de Veer, a senior principal expert at SIG. Rob is an AI pioneer with 32 years of experience in the AI field, specializing in software engineering, security, and privacy. He is the lead author of the ISO IEC 5338 standard on AI lifecycle, co-founder of the Digital Bridge for Security Standards, opencer.org, and creator of the OWASP AI Exchange, open sourcing the global discussion on AI security. Wow, that's a lot, Rob. Rob will talk about how he designed the ISO IEC 5338 standard and to help integrate software best practices into AI engineering, and how to make AI systems secure using the OWASP AI Exchange. Welcome, Rob. How are you today?
Hello, Yohai. I'm great. I'm looking forward to this very much. Thank you for inviting me.
Excellent. I'll hand over the spotlight and mic to you.
Thank you very much. If everything is well, you can see my screen.
Yep.
And I welcome you all to this session. I believe by now we can all agree that AI creates tremendous opportunities, right? It's changing our lives, changing our businesses. But how do we make it work without getting into trouble? And today I will share many best practices with you and some great resources to help with that. Because we see many organizations bringing AI out of the lab into real world applications, and often for the first time. And then it suddenly needs to be reliable, secure, lawful, maintainable, transferable, scalable, ethical, etc. And when clients ask me how to make this happen, I typically say to them, keep calm, AI is just software. It's just something you need teams for, and a life cycle, and testing, and documentation, and an ISMS. It's all stuff that you are familiar with. So that's great. However, there's also this interpretation. Total panic. AI is software. Because we may be familiar with how we produce software. And the human race is not really known for producing great software. Secure, reliable, future-proof. We have a pretty bad reputation. So I'm afraid we can expect some problems with AI because it is software. And today I want to dive into this with you, hoping to give you some guidance in making AI work for your organization. So as said, I have a lot of experience in AI. I work for Software Improvement Group, helping clients all over the world to create good software. I worked on a bunch of standards, still doing that, including the AI Act. I want to start by setting the stage for our discussion by going over the many roles that AI has in software engineering, because sometimes this can be confusing, also for me. Developing a system. That's a use case, clearly. Developing a system that uses an AI model. Then you can also use AI to write a system, using ChatGPT to write your code, explaining code, improving code, and also to review code, classifying static analysis findings, explaining findings. So using AI to create a system. Then another category is using AI to defend the system. And we've seen, over time, a lot of AI systems, algorithms trying to detect suspicious patterns or malware or network traffic. Those are examples of using AI to defend the system. And of course, using AI to make text systems. Personalizing phishing mails, for example, is something that is mentioned a lot. Large language models can really do that well. And last but not least, the category of AI helping you to get answers to your questions as an attacker, as a defender, as a programmer, as a tester. And let me show you an example of this. This is something that we built with the OpenCRE team. It's OpenCRE Chat, the world's first security chatbot, something I'm very proud of. And it's an open source system, OpenCRE, that integrates all security standards into one resource. And because we have all these security standards and their texts, what do you do in 2024? You put it into a large language model. And then you can ask questions for which it will use these security standards primarily. So it will give you a more reliable answer. and you get a nice reference to the most relevant standard. I recommend to check it out. It's free, even if you don't speak English well, it will speak your language. The first response we got was from Japan, and we realized then, oh yeah, it's a large language model. It doesn't really bother about what the input and output language is. It's amazing. And of course, it still hallucinates sometimes because it is a large language model, and that's part of the game. So that's getting your questions answered with AI. What's next? Let's talk about designing and building software systems using AI to generate code. So basically, the GitHub Copilot use case or AWS Code Whisperer, Google Duet. We really recommend using products like that and to gain experience step by step to see what works for you on the short term, but also take into account the long term, and it will help you become more productive in programming. And there are a couple of attention points. First of all, AI generated code has quality issues. This may not surprise you, certainly after the sessions of today, just like any other code. It was trained on the internet, right? So what could possibly go wrong? Large language models, the AI behind these coding assistants, they work by association. They induce, and they're amazing at it. They guess, so to speak, and they do have a form of understanding, but it's different from typical human understanding. So it can make mistakes that you sometimes don't expect. Like it can create a reference to an open source component, let's say an interest calculator, that simply doesn't exist. And then a hacker can quickly create that component, and there you go. They are in your system. In other words, it's important to check the code that AI generates. Programmers need to get familiar with it anyhow, because they will be maintaining that code, that generated code, not the instructions that they typed in to get the code. Code remains the currency. That's really important to realize. And because programmers need to be able to maintain that code, how do we make sure that they keep gaining experience in the necessary coding and problem solving and building up perseverance in problem solving and patience? Being in an environment where the majority of code can be generated, that's a challenge. And if we don't manage this, the current senior engineers are going to be the last of their kind. Well, of course, we're not going to let that happen, but it requires some discipline. We need these programmers to stay actively involved. Just like research has shown that car drivers in a self-driving car need to keep driving. They shouldn't sit back to see if the car is doing everything right, because humans turn out not to be capable of that, because there's something like review fatigue. They shouldn't just review because they will get tired and assume things will go well. Furthermore, checking code is, of course, as said, important, and it can be a challenge. It doesn't go through the hands of engineers, so you need to arrange manual code review consciously. In fact, programming is shifting from typing code to reviewing code. And it requires more skill to review somebody else's code than you need to write the code yourself. Let me repeat that. It requires more skill to review somebody else's code than you need to write the code yourself. This is counterintuitive, but it is reality. And this is also why AI is not very good at code review. I left a link here for some recent research. We're doing research ourselves at Software Improvement Group, showing that they're not particularly great at code review. And here's the thing. Experience in a team is typically rare, but you need it to do code review. So the team will have to wait on the experienced programmers to get their review work done. And the typical result will be that it's very tempting to rush the review work so you can gain the productivity increase, because the review capacity becomes the cap on your productivity. And it is easy to rush this, intuitively, for issues where you pay the price later, because that's hard to detect. Security issues or maintainability issues, which is also why automated code analysis is a great addition to this code review practice. And these issues of rushing are likely to happen because most engineers are not very fond of code review. Now, This may all sound a bit grim and like I'm not a fan, but I am a big fan of using LLMs for coding. But it's also a big risk if you don't do it well. And you can manage it, although it will require discipline because you need to counter people's natural behavior. Keep engineers involved in actual programming, apply a strict reviewing policy, and by doing so, your productivity will increase without creating a mountain of technical debt in your code and in your people. All right, let's now talk about developing AI systems. Many organizations are doing this. And when you develop your own system that contains an AI model, you really should start with taking responsibility for AI. Set up your AI governance. That means you keep track of your AI initiatives, you perform risk analysis on them, you set requirements, you assign responsibilities, and you involve your stakeholders. Only then you can manage AI. And a recent standard for this, the 42001, but NIST also has some nice recent work on this, will guide you in applying this AI governance. Then, for each AI idea, whether it is new or existing, you need to do a couple of checks. Obviously, is the application area legal? Because some things are forbidden. I used to apply AI in crime analysis, and some of those applications are now actually going to be forbidden by the AI Act. May you use the personal data for the purpose that you intend? Do you really need AI to solve the problem? Do you have access to the right expertise? Do you have data scientists on board? Can you control the risk of harm by human oversight and provide the right accuracy? Can you provide the legal and ethically required transparency into how your AI works? And last but not least, can you prevent unwanted bias sufficiently? Some of these issues are inherent in the problem, and it's better to realize this before you start than getting sued and letting a judge decide whether you should have checked before you started. And then when you start programming, it's important to be aware of typical problems in AI development. AI often suffers from poor code and lack of software engineering discipline. It's almost as if normal software rules don't apply to AI teams, but they should. AI teams have mainly focused on creating a working model in their education and most of their working life, not per se on developing a future-proof, reliable software system. Now, at Software Improvement Group, we did some research on this topic, and you see the results here. Thousands of systems in our benchmark with a volume, and which is their size on the horizontal axis, and their quality on the vertical axis. The blue dots are the AI systems. As you can see, the majority of these score well below the industry average. And when working with our AI clients, we observe a general lack of engineering discipline. For example, the testing code is just 2% of the total code volume, where in the benchmark, this is 43%. It's an incident or a failure waiting to happen. So what can you do about it? Well, treat production AI for what it is, professional software. Involving AI into your regular software engineering program. Let your data scientists apply versioning and let them document their experiments for a change. Measure the quality of their code. Otherwise, you'll be dealing with unmaintainable code that cannot be transferred to other engineers. Now, there's nothing wrong with data scientists. They're great. I've been a data scientist, but I was also very much focused on creating working models and not on future-proof software. So I needed help. I'd like to refer you to a great resource to make this happen, although I'm a bit biased. I was the lead author of it. It is the ISO 5338. Worked 3 years on it, was released last December. All agreed with the 30 countries involved in ISO IEC. And it's built on the AI framework by the Software Improvement Group. The great thing about it, it doesn't introduce a completely new lifecycle. It builds on the existing lifecycle and discusses what is new and what is different. There's no time to go into the details. You can have a look. And that, by the way, is a free test. The 5338 costs about $170. If you fail to get your organization to pay for that, your organization is not ready for AI. It's a great maturity test. Now, of course, an important part of your system lifecycle is security. So it speaks for itself. you need to apply software security best practices as well. Risk analysis, security training to your data scientists, setting requirements, penetration tests, everything. And we see this being overlooked very often. Now, if you want to know more about this, you'll find some great resources at OWASP. For example, the Large Language Model Top 10, the OWASP AI Exchange. And I started that 1.5 years ago to bring together experts from around the world and from many disciplines with the goal to collect AI security threats and controls in a comprehensive overview. And that's what we did. Currently 140 pages of material, and it's completely copyright free. And that allowed us to feed this straight into the ISO 27090 standard, which is on AI security, and into the standardization process for the AI Act. We basically open sourced the whole AI security discussion, and I'm very, very proud of that. And we want this to be the wheel that doesn't have to be reinvented. So we also actively collaborate with standard makers, including CSA, ISO, NIST, MITRE, ITU, NCSCs, and we're part of the AI Safety Institute Consortium. Let me show you some of the threats and controls that we identify at the exchange. And I will go through this very fast because of the time, but it will give you an impression. So a super basic representation of an AI system. And I'm going to take you through 3 categories of threats organized by attack surface. First of all, threats by using the model. And here you see the typical adversarial machine learning threats, but also prompt injection for generative AI. Each threat refers to a letter in the impact. The impact of evasion and prompt injection is that the model behavior is manipulated, but the impact of membership inferences, confidentiality of the training data is at stake. Next, the second category, development time threats. AI systems have unique assets in the engineering environment, training data, and model parameters. These can be stolen or manipulated before the model is running in production. Then last but not least, the threats during runtime. For example, processing model output that has injection attacks. And mostly we see conventional security attacks here, like SQL injection, password guessing, and notably input leak. Especially in generative AI, this is a big one. And it's not in the top 10, by the way. Many applications of large language models construct a long prompt, as you know, and often with company secrets in the context. And when this travels to the model, likely in the cloud, this introduces all kinds of risks. So that's input leak. Here's the complete picture. Now, there are 54 controls in the AI exchange, and we can paint them in this picture. First of all, the development time controls, your governance, your development environment security, and a lot of controls that are data science controls. So your data scientists doing adversarial distillation, federative learning, many new things for security people, things not to be get proficient in, but to educate data scientists on. Runtime, there's of course controlling access to the model with authorization, limiting, monitoring, additional runtime security, mostly conventional stuff. And last but not least, also here, work for data scientists for filtering and detecting input to prevent attacks. Then the final category is limiting impact, minimizing data and controlling behavior, because you need to assume that at some point the model can have been manipulated and you need to control the impact and not rely too much on that the model is going to be right. I'm wrapping up. Don't be too overwhelmed by AI. It's just software. And so to be successful, you need to build on your existing way of working for software engineering and for security. Set up AI governance. Think before you start. Get acquainted with AI-specific threats and controls. Include those in your security management system and your secure software development. Tag your data scientists along, and everything is going to be just fine. Good luck, and back to you, Yochai.